So today, we're going to talk about a really radical shift in how we get visibility into our networks. We're moving away from these expensive, closed-off boxes and into a future that's all about open, software-driven solutions. We'll break down how this big change, powered by an open-source system called SONiC, is making our networks faster, cheaper, and way more secure. All right, let's jump in.
I mean, it's a massive challenge, isn't it? Every single year, the amount of traffic just explodes. You've got AI workloads, cloud services. It's a literal tsunami of data. And trying to find that one malicious packet or that one little performance bottleneck in this gigantic ocean of data, it can feel completely impossible.
And that is exactly where this piece of tech comes in, the Network Packet Broker, or NPB for short. You can think of it as the ultimate traffic cop for your network. It sits there intelligently copying traffic from your main data highways, and then it directs those copies over to your security and analysis tools. That way, they can inspect everything without ever slowing down the actual network. It's pretty clever.
But, not all packet brokers are created equal. To really get where we're going, we first have to understand where we've been. This technology has actually gone through a pretty fascinating evolution.
This slide really tells the whole story. So the first-gen MPBs, they were built on FPGAs, these specialized programmable chips. Super powerful, yeah, but they came in these expensive, proprietary boxes that locked you into a single vendor. Then came the second generation, which moved to a programmable P4 ASICs. These were more cost-effective, but still really complex to manage. And here's the kicker. Those second-gen chips are now hitting their end of life, which is forcing a change. And that brings us right to the third generation, open network.
And this is where things get really exciting. Because this third generation is not just a small step up. It's a completely new way of thinking. An open, software-defined approach that basically changes the entire game.
I just love this analogy because it makes a really complex idea so simple. Instead of needing some specialized single-purpose box, the new MPB is just software. It's an application, and you can install it on a standard network switch, just like putting an app on your phone. It's that simple, but what it can do is incredibly powerful.
So here's the most important part to remember. We're talking about an open architecture built on two key things. First, you have SONiC, which is the open source network operating system that's just taking over the data center world. And second, you're running it on universal, off-the-shelf switch hardware. No more proprietary lock-in. That's the big deal. And this slide just lays it all out, doesn't it? We are moving away from that old world of expensive proprietary boxes and total vendor lock-in, and we're stepping into this new world of open software running on common hardware. And the result? Well, you get way more flexibility, a ton more control, and a much, much lower total cost of ownership. Okay, so what can this new architecture actually do? Let's take a look at how it delivers a whole rich set of features, but without all that old complexity. The real beauty of this whole approach is that you don't sacrifice any capability. You get all the standard features you would expect. Things like filtering traffic and load balancing. But you also get these really powerful advanced features, like packet deduplication, which cleverly removes redundant data to save your tools from getting overwhelmed, and TCP reassembly, which pieces together fragmented data streams so your tools can do a much deeper, more meaningful analysis. And here's the really brilliant part of the design. Those standard high-speed functions, they run directly on the switch's main chip, the ASIC. But for the really heavy lifting, the processor-intensive advanced features, the system is smart enough to offload those tasks to an optional DPU, or a data processing unit. It's just a super efficient way to put the right workload in the right place for the best possible performance.
This new model also completely changes how you manage the network. Forget manually configuring rules one by one by one. This solution fully embraces modern DevOps, integrating with tools like Ansible. So now, network teams can create and deploy templates to push out thousands of policy changes in a matter of minutes, not days.
And of course, after you've automated the deployment, you get to see all the results in real time. With native integration into awesome platforms like Prometheus and Grafana, you get this powerful, unified dashboard view of everything that's happening. No more flying blind. You can just easily monitor system health, traffic rates, and packet drops, all from one place.
So that's the tech. But what's the real-world payoff, right? Let's talk about what this all means for performance, for scale, and everyone's favorite topic, for your budget. 800G. Just let that sink in for a second. 800 gigabits per second. That number is a complete game changer for network visibility. And that number, that 800G, it's a direct answer to the insane traffic demands we're seeing today.
This right here is the hardware that makes it happen. As of right now, it's the industry's only packet broker that supports 800G speeds. It was built from the ground up to handle that fire hose of data you get from AI training and these massive hyperscale data centers. It's filling a huge gap in the market.
Okay, so an 800G port is incredible, for sure. But what does that speed actually let you do? How does that translate to a real-world benefit beyond just a big, impressive number?
Well, it all translates to density. Using something called a breakout cable, you can take a single massive 800G pipe and you can split it into multiple smaller, more usable ports, like turning it into 800G ports, for instance.
And when you do the math on a fully loaded switch, well, the results are just staggering. A single one of these devices can be configured to give you up to 512 high-density 100G ports. Think about that. That means you can connect a massive number of traffic sources and analysis tools to just one box. It's incredible.
And the cost savings are also a really big deal. Just take a look at this. In a traditional setup like you see at the top, if you wanted to monitor a long-distance link, you'd need 4 very expensive ZR optical modules. But with this new solution's inline mode, at the bottom, you actually place the NPB directly in the data path. This radically simplifies the design and means you only need 2 of those expensive modules. You are literally cutting your long-range optics cost in half.
And that inline deployment, it does a lot more than just save you money on optics. It simplifies your entire network topology. It lets you create these really smart security service chains where you can direct traffic through multiple tools in a specific sequence. And it even lets the packet broker actively check the health of those tools and automatically reroute traffic if one of them fails.
Okay, we have covered a ton of ground here. Let's bring it all home and quickly recap the most crucial points of this whole next-generation solution. So to sum it all up, here's why this really matters. It's built on standard switch hardware, so you're free from those proprietary end-of-life cycles. It's based on the open SONiC architecture. It gives you a super flexible deployment model, it dramatically lowers your total cost of ownership, and, most importantly, it future-proofs your network for 800G speeds and whatever comes next.
And really, that brings us to the final question you should be asking yourself. With this data tsunami only getting bigger, is your current approach to network visibility holding you back? Is it built on the closed, expensive principles of the past? Or is it truly engineered for the open, scalable, and cost-effective future?